Hello, friends. Welcome to another session with me for Quant. So, if you are in this channel for the first time, then what we talk about this channel is Quant and DIL are topics primarily for CAT, NMAT, SNAP, IFT, or any other MBA entrance exams in India. But if you are appearing for non-MBA entrance exams also, these sessions are very helpful for clearing certain foundational concepts or certain problems to see how to solve them quickly. What are the tricks on the that you can apply in certain concepts level problems like time, speed, distance, arithmetic, your percentage profit and loss, and in algebras like linear quadratic equation, logarithms, and stuff like that. What we are going to do today, we are going to talk about a topic that is very, very relevant for CAT and very, very important as well. So in the previous session, we talked about the fundamentals of quadratic equation. Now in today's session, we are going to talk about quadratic equation problem 1. So basically problem 1 means this is the foundational level problems which will help you understand what you have learned from the foundational class. So these are conceptual clarity level problems which may not be very complex. There will be certain problems with certain twist or certain nuances into it, not a straightforward kind of a problem. That also we will solve in today's session. But along with that, we will focus on building or cementing your foundational understanding from the previous session. So if you have not seen the previous session on the basics of quadratic equation, I urge you to please go through that first and then come to this topic, a very, very important topic for your CAT. Every year you can expect around 2 problems surely from this area, minimum 2 problems in CAT, that kind of a scenario. In MAT, SNAP, IFT, the number is little more. So absolutely a must chapter for you. You cannot miss this chapter. So please be mindful and be with me for the next 30-40 minutes while we try to solve the problems. And one more thing, once we solve the problem, just don't try and see my solution right away. You can pause the video, see this, try it by yourself. If you are able to solve, come back and see my approaches. Or if you're not, after 2-3 minutes, come back and continue the video and see how am I solving this problem. So with that, let's get started. So let's see the first problem for today. You can see it says find the quadratic equation whose roots are 7 and 10. Now we know what is the generic form of quadratic equation. I'm quickly revising: x square plus bx plus c equal to 0. This is the generic form of any quadratic equation. Now, if we know the formula, if we know the individual roots, then we can write the equation as, since there are 2 roots, okay, what we learned, if a, b are roots of a quadratic equation, then the equation can be written as x minus a into x minus b equal to 0. That's what we learned from the previous class. So we can directly apply. So this is x minus 7 into x minus 10 equal to 0, or x square minus 7x minus 10x plus 70 equal to 0. Or we can say x square minus 17x plus 70 equal to 0. So this is the equation. So if you know 2 roots, how to make it a quadratic equation, absolutely basic and foundational level problem. Let's go to the next one. So this session is primarily on making your basics absolutely clear through problems, and then in the next session we'll go advanced level problems. So this is very important session, and we will also cover a few of the CAT or XAT questions this year. So in this chapter, so it's not right to assume that these problems will not come in CAT. These problems can very much come in CAT, XAT, or IFT, or any other entrance exam, but these problems also needs to be solved along with the complex problems that we are going to talk in the next sessions. So let's get started for this. So this problem, it talks about find the sum of the roots and the product of the roots. So sum and the product. So again, if equation is ax square plus bx plus c equal to 0, we know sum of roots, again deriving from your basics class, sum of roots equal to minus b by a, and product is c by a, right? So in 5x square plus 7x plus 15 equal to 0, if I equate with this equation, what is sum? My sum will be minus b by a. So b is 7 here. So minus 7 by 5 is my sum. And my product will be c by a. So 15 is my c and a is 5. So product is 3. So this is the sum and sum of the roots and the product of the roots for the first one. This is 8. Similarly for b, 7x square minus 48 equal to 0. Now if we equate here, so from here I know a is 7, b is 0, c is minus 48, right? If I equate with the first equation, there is no x term. So if there is no x term, then the b coefficient must be 0 and c is minus 48, because with the standard equation, it's ax square plus bx plus c equal to 0. So my sum, which is minus b by a, has to be 0 because b is 0. My product will be c by a, so minus 48 by 7. Okay. So that's how we can do it. So basically, you know what is the formula of getting sum and the roots of the equation, and what are the how to write an equation if you know the two roots already there. Yeah. Okay. Let's move on. They said if the roots of x square plus kx plus 169 are equal, find the value of. So if you remember, if our equation is ax square plus bx plus c equal to 0, then we can say the equation can be written as, or the solution of that equation is minus b. This is the most generic form of quadratic equation solution by 2a. So this is the solution. In that, the thing under the root, that is b square minus 4ac, is called discriminant. So b square minus 4ac is called discriminant, or we commonly known as d. Because so to become the roots are equal, what we understand, again recalling the previous session class, we said d has to be equal to 0. If d has to be equal to 0, then the value under the root becomes 0. So this becomes x equal to minus b plus minus root over 0 by 2a, or minus b by 2a. So both the roots are similar and equal to minus b by 2a. So that's when we say d has to be equal to 0. Now what is d here? In x square plus kx plus 169 equal to 0. Here your a is 1, b is k, and c is 169. If I compare with the standard equation ax square plus bx plus c equal to 0. So I know this. So what is b square? B square must be k square minus 4 into 1 into 169. This is equal to 0. So we can say k square is equal to 4 into 169. So k is 2 into 13 plus minus. Because the square, so k we can say plus 26 or minus 26. So the values of k can be plus 26 or minus 26, right? So that's when the roots of the equations are going to be equal. Again, if you have any doubt in understanding certain problem, please drop a note, or certain areas or certain steps that you are not understood, please drop a note in the comment. If you want a little more clarity on how we are approaching this, or you want guidance from me, you can drop me a mail in the mail ID given in the description box, and we can take it from there. But absolutely must is going through the foundational session that we have taken. I'll put the link in the description box, and please go through that before you start solving or start seeing this video, so that you can relate whatever the formula and whatever the conditions, what are the scenarios we are taking up here, absolutely explained in great detail in the previous session. Okay, now the next one is find the equation whose roots are 1/3 of the roots of x square minus 8x minus 36. So if you remember what we said that in my class we said if alpha beta, or we said if alpha beta are roots, then the equation is x minus alpha into x minus beta equal to 0, right? If alpha beta are the roots of the equation, we said x minus alpha into x minus beta has to be equal to 0. So this is the first one that we have covered. Or we can say if a, just a minute, we can say if ax square plus bx plus c equal to 0 is an equation whose roots are alpha and beta. If this is the equation, then if both of the roots are multiplied with 3 or multiplied with k, so if an equation is there whose roots are k alpha and k beta, your equation will become a into x by k whole square plus b into x by k plus c equal to 0. Now in this case, we said the roots are 1/3. So roots are 1/3. So can I say my original equation is x square minus 18x plus 36 equal to 0. So can I write x by 1/3? Because 1/3 time, so if this has roots of alpha beta, now we are trying to find out an equation whose roots are alpha by 3 and beta by 3. So that means multiplied by 1 by 3. So x by 1 by 3 minus 18 into x by 3 plus 36 equal to 0. Right? Sorry, not x. Sorry, x by 1 by 3 plus 36 equal to 0. So this is given. Let me just use it a little. So this is 3x whole square minus 18 into 3x plus 36 equal to 0, or we can say 9x square minus 54x plus 36 equal to 0. If you take 9 common out of all this, so x square minus 6x plus 4 equal to 0. So this is what it is all about, minus 6x plus 4 equal to 0, right? So that is the equation or the solution of this equation, right? Okay, I hope you have understood this problem. And with that, let's move to the next one. So like we said, again, recalling what we have covered in the previous session, if roots of the equation is alpha beta and then the alpha beta is multiplied by k, then your x in the new equation will be divided by k. If it is divided by k, it will be multiplied the x with the same equation by k. If k is added, then so basically if I'm saying if the new root is alpha plus k and beta plus k, then your new equation will become a into x minus k whole square plus b into x minus k plus c. So whatever you do to the roots, the opposite happens to the x's in the existing equation. So please recall the previous session where we have in-depth covered all these scenarios. So what they said, two of the roots of the equation are -3 and -2, -3 and 2, find the other two roots. Okay, so if I see -3 and 2 are roots of the equation, so can I say x plus 3 into x plus x minus 2 must be equal to 0, not must be equal to 0, sorry, are two factors of the equation. If so, basically I'm saying x equal to -3 and x equal to 2. If I put in the given equation, the equation will become 0. So that means x plus 3, because that's why -3 and 2 are the roots of this equation. So x equal to -3 if I put in the equation, and x equal to 2 if I put into the equation becomes 0. So that means x plus 3 and x minus 2 are two roots of this equation, right? A similar way we did the first problem. So if these are the two roots, then this can be written as x square minus 2x plus 3x minus 6, or x square plus x minus 6. So this must be a factor of the equation. If this must be a factor of the equation, I just need to figure out what will be the other factor of this equation, right? I have to find out what is the other factor of this equation. So x to the power 4, that means there should be 4 roots. We got 2 roots. Let's see what are the other 2 roots. So I know x square. I know x square plus x minus 6. Let's say this is equal to 0. And I am trying to make it equal to what is given. X to the power 4 minus px cube minus 2x square plus 4x plus q equal to 0. Okay, so this is given, right? Okay, before trying to solve the problem, let's see if we can get the values of p and q, because p and q are unknown typically. So I know for a fact that if I put x equal to -3, I should get the equation equal to 0. So let's ignore this part as of now. So from here, we can write, if I put x equal to -3, then it becomes, first one becomes 81 minus p into -3 whole cube minus 2 into -3 whole square plus 4 into -3 plus 2 equal to 0. Or we can say 81 minus 3 whole cube is -27, minus minus become plus 27p. This is 9, so minus 18 and plus 4x plus q, 4x plus q. So minus 18 minus 12 plus q equal to 0, or we can say from here 27p plus q is 81 minus 30, so that is 51. So 27 plus q is minus 51. So this is one part of the equation, right? Now similarly, if I do the other part, if I put x equal to 2 in this equation, it should also solve. So if I put x equal to 2, then it becomes 16 minus 2, x cube is 8, so that means minus 8p. X equal to 2 means x cube is 8 minus 2x square. Minus 2x square is 2 square, that is 4. So minus 4p plus 4 into 2. So that means 8x plus q equal to 0. Sorry, this one is not p. 4. So second one is 8p, second one is 2 square is 4, so that is minus 8. So this is minus 8, not p. Let me write it again. I think first part is C. So I'm putting it 2 here. So that means first part is 16, then it's 8p, then it's 2. So x square, if I put x equal to 2, then x square become 4. 4 into minus 2 is minus 8. Plus next one is 4x, 4 into 2 is 8. And the last one is q equal to 0. So 8 get cancelled. So we can say 8p minus q is 16. Okay. So these are the two equations we got. Now with this two equation, we got 27p plus q. Let's say this is equation 1, this is equation 2. If I do equation 1 plus 2, what I'll get? 27p plus q and 8p minus q. So q will get cancelled. So I'll get 35p, 27p plus 8p, 35p, and minus 51 plus 16, that is minus 35. So can I say p is minus 1? And in this equation, if I put p is minus 1, so 8 into minus 1 minus q is 16, or this is minus 8 going to the other side. So this is minus q is 16 plus 8, or I can say q is minus 24. Q is minus 24, right? So if I know p is minus 1 and q is minus 24, so these are the two equations we got. Let's see if we can further narrow this. So I hope you have noted the problem. So we are narrowing it down so that we use this space. So just keeping it here so that it's visible to you. Okay, so let's see if we can use the problem. So now what is my equation has become? My equation has become x to the power 4. Okay, use this. My equation has become x to the power 4 minus px is cube. P is minus 1. So minus minus become plus. So plus x is cube minus 2x square plus 4x plus q, so become minus q, so minus 24 equal to 0, right? So this is my equation right now. Now what I have to do, I know x square plus x minus 6, so this is already one factor. So x square plus x minus 6 is already one factor of the equation. So I have to see how I can get the previous equation. So if I multiply this with x square, my x to the power 4, the first term I get, then the next term become x cube. So this term also I'll get. So if I just multiply this with x square, I'll get the first two term right. Then the next term is minus 6x square. So first term x square into x square is x to the power 4. So the first term is taken care. The next term is x square into x plus x cube. So that part is taken care. The next part is minus 6x square. But in problem, I have minus 2x square. So if I do another round, x square plus x minus 6, I have to put 4. So minus 6x square from the first multiplication plus 4x square from the next multiplication makes it minus 2x square. So 4, so this part is taken care. 4 into x makes it 4x, so that part is taken care. 4 into minus 6 minus 24, that part is taken care. So this is 0. So my final equation become x square plus 4 into x square plus x minus 6 equal to 0. So this is my final solution of the given equation. So with this, I know this part needs to be solved. So I know x square plus 4 equal to 0. So x square is minus 4. X is equal to plus minus 2i, because it's a complex term, because x square cannot be negative in a real number. So x equal to plus or minus 2i. So the other two root is plus 2i and minus 2i, right? So these are the other two roots of the equation. It's a very good problem. If you have any doubt, please drop a note. So what we did, we took first x minus 3 and 2 are the two roots, so then become x plus 3 and x plus 2 are the x minus 2 are the two factors of the equation. We multiplied and make it a single factor of the equation that we kept aside. Then we put the values of -3 and 2 and try to get the value of P and Q by forming two equations, because -3 and 2 should satisfy the equation. From there, we got the value of P and Q. We rewrite the equation by replacing the value of P and Q, and then use the factor we have got in the past, that is x square plus x minus 6. We try to get the other factor. And from the other factor, we try to find out the other two roots, which is 2i and -2i. Okay. A very, very good problem, but hope you get it. If you are not, absolutely fine. You can drop a note in the comment section. I'll be able to respond. Or if you still not clear, you can drop me a mail. We can arrange a one-on-one session where we can explain you, or I will give you a detailed explanation in one mail only. So if alpha beta are the roots of the equation, alpha beta are the roots of the equation. So I know alpha plus beta should be minus b by a, so that is -6. And alpha beta is c by a, that is 11. So let's do a little simpler one, because the previous problem was a little heavy. So this one is 1 by alpha plus 1 by beta. So this is alpha beta into alpha plus beta. So alpha plus beta is -6, alpha beta is 11. So -6 by 11. Absolutely straightforward. Okay. So let's move to the next one. I hope it's clear. So R and C are real number. R and -R are the roots of 5x cube plus cx square minus 10x minus 9 equal to 0. Okay. R and -R are the roots, right? So R and -R are the roots. So if I put R and -R into the equation, I should get the m is equal to 0. So let's put, so the first one is 5r cube. I'm putting r, 5r cube plus cx square, cr square minus 10r plus 9 equal to 0. So this is one equation. The other equation is -5r cube. This will be cr square, even if you put -r, because minus minus get plus. Minus square is plus. So 10 into -r. So this will be plus 10r. And this part is 9 equal to 0. So this is equation 1. Let's say this is equation 2. So if I have to nullify c, I will do 1 minus 2. That becomes 5r cube minus 5r cube. So that becomes 10r cube. Cr square minus cr square will get cancelled. And then we have minus 20r equal to 0. 9 and 9 will get cancelled. So then can I say 10r cube is equal to 20r, right? So 10r cube is 20r. So can I say 10r square is equal to 20, or I can say r square is 2. From here I can say r equal to plus minus root 2. R equal to plus minus root 2. Now I said r and c are real number. What is the value of c? So you know r equal to plus or minus root 2, and you know this is the equation. So if you put the value of r in the given equation, you should be able to solve the problem. Now, how to put this value in the equation? Let's do this, or let's use this a little more. So I know r equal to root 2 and r equal to minus root 2 are the two equations. So if I put it in the then x minus root 2 and x plus root 2 are two factors. Then let's say the third root is, because it's a cubic form equation, so then there are three values of x, because 5x cube is the degree of the equation, that is the highest power. There will be three roots, so let's, the third root is k. So then x minus k will be another factor. So this must be equal to 0. So let's simplify. So then this becomes x square minus 2 into x minus k equal to 0, right? Again, further simplifying, this one become x cube minus kx square minus 2x plus 2k equal to 0. This is the equation that we got. And what is the equation given to us? 5x cube plus 6cx square minus 10x plus 9 equal to 0. So from the first difference I can see with the given equation, this equation is here x cube coefficient is 1. In the right side, the coefficient is 5. So if I just divide this equation with 5 and make it equal to the x cube that we got, or equal to the left hand side x cube. So if I divide with 5, this will become x cube plus c by 5 x square minus 2x plus 9 by 5 equal to 0. So this is what I will get. Now if you compute with this equation and this equation, if you compute, x cube has the same coefficient. The next one is minus k, I can say, is equal to c by 5. Minus x has the same coefficient and the first coefficient is 2k. So and then I can say 2k is equal to 9 by 5. So from here I can say k is 9 by 18. Sorry, k is 9 by 10, not 18, 9 by 10. K is 9 by 10. So if I put this value back here, I can say what? I can say C is equal to minus 5k, or minus 5 into 9 by 10, or minus 9 by 2. Minus 5. Yeah. So C is minus 9 by 2. But this is the equation value of C. So again, a very good problem. We put R and minus R. We got a value of R. Put that into the, make that as a factor of the equation and consider the other other root as K. Put that value, solve everything, and whatever the equation we got, we tried to equate with the given equation. And from by equating that with the given equation, we got the value of C. Right? So we got the value of K, and in one place in terms of C, in the other place we got K as a constant term. So just got the value of K and then put it back, we'll get the value of C. Okay. The next problem, we said x square plus 5x plus 7 equal to 0 has roots a and b. 2x square plus px plus q has roots of a plus 1 and b plus q. Find the value of p plus q. Okay, fine. So x square plus 5x plus 7 has roots of a and b. So I know x square plus 5x plus 7 equal to 0. Sorry, 5x minus 7 equal to 0, and roots are a and b. So we can write sum of root is minus b by a, so minus 5, and ab is c by a, that is minus 7. Right? Now some equation has a root of a plus 1 and b plus 1. So I can write that equation as x square minus. So if I know the two roots of the equation, then we can write x square minus sum of the roots into x plus product of the root equal to 0. Again, recalling the similar concepts that we have taught in the previous class, x square minus sum of roots into x plus product of root equal to 0. This is another way of writing an equation, right? So x square minus a plus 1 plus b plus 1 into x plus a plus 1 into b plus 1 equal to 0. So x square, if alpha and beta are the root of the equation, like we said, we can write this as x square minus alpha plus beta into x plus alpha beta equal to 0. So this is one way of writing our equation. If you know their roots, x square minus sum of the roots into x plus product of the roots equal to 0. Right? So, okay. Now, this is what we got. So from here, let's say simplify this x square minus a plus b, we know minus 5. So minus 5 plus 2 into x plus, if I simplify this, this becomes ab plus a plus b plus 1 equal to 0. Again, we should simplify this x square plus 7x minus 5 plus 2 is minus 3. Minus 3 come outside, become plus 3. So x square plus 3x plus ab is minus 7. Minus 7 plus a plus b is minus 5 plus 1 equal to 0. So that is minus 11. So we can say x square plus 3x minus 11 equal to 0. And in the given set, you have 2x square plus px plus q equal to 0. So again, x square coefficient, we have to make it equal. So divide the right side equation by 2. So x square plus p by 2x plus q by 2 equal to 0. So from this we can write p by 2 is 3. From here I can write p equal to 6. And then q by 2 is minus 11. So just equating this equation and this equation, right? So then we can say q by 2 is minus 11. That gives me q as minus 22. So what they have asked, p plus q. So p plus q is minus 16, right? So I hope you got this. Okay, so we got p plus q. So again, what you have seen is we know certain things, we put it into the equation, create an equation and equate with the given equation and find the unknown of the given equation from the equation that we have created. Okay, this is clear. Let's move to the next problem. It says sum of the roots in a quadratic equation is 5 less than the product of the roots. So sum of the roots of a quadratic equation is 5 less than product of the roots. So let's say the roots are alpha beta, right? If the roots are alpha beta, can I write alpha plus beta is 5 less than the product of the roots? So alpha beta minus 5. If one root is one more than the other root, find the product of the roots. One root is one more than the other root. So alpha, let's say, equal to beta plus 1. Right? Alpha equal to beta plus 1. Find the product of the root. So basically, you have to find out alpha and beta. So from this equation, you just replace in this equation, replace alpha with beta. So let's say beta plus 1 is equal to alpha is beta plus 1 into beta minus 5. So we can say beta plus 1 is beta square plus beta minus 5. Right? Alpha plus beta, beta plus 1. Okay, there is alpha is beta plus 1. So there is also another beta here. That's right. Okay, so from here we can get 2 beta plus 1 equal to beta square plus beta minus 5. So we can say beta square, 2 beta on the right side. So that is minus beta. Beta minus 2 beta is beta. And minus 5 minus 1 is minus 6 equal to 0. So we can say from here beta minus, if you solve this, you will get beta plus 2 into beta minus 3 equal to 0. Or we can say beta equal to minus 2 or 3. If beta equal to minus 2 or 3, then putting it here, alpha is when beta is minus 2, alpha is minus 1. Alpha is minus 1 when beta is minus 2. And similarly, when beta is 3, alpha is 4. Alpha is 4 when beta is 3. So the product is 2 or 12. Minus 20 minus 1 is 2. 3 into 4 is 12. Straightforward. Let's move to the next one. Okay, find the value of x and y. So you know, if we have an equation, so first one is a square and the second one is also a square. A square plus b square equal to 0. Now, none of the square can individually be 0 if these are real numbers. So each of them individually, a will also be 0, b will also be 0. Then this is the only possibility if the sum of our squares are 0. So from this one, I can write 3x plus 2y minus 22 equal to 0. 4x plus 5y plus 9 is also equal to 0. If this is given, so from this one I can write 3x plus 2y equal to 22 and 4x plus 5y is equal to minus 9, and they have also given 5x minus 4y equal to 0, and they have asked you to find out the value of y. Okay, so let's say this is equation 1, this is equation 2, and let's say this is equation 3. Now if I think so how to find the value of x and y, right? So from here you can easily get the value of x and y in multiple ways. So let me see if there is a easy way to do it. Okay. Now let me just go through this. Okay, now if I see 1 has 3x plus 2y and 3 has 5x minus 4y. Okay, 5x minus 4y. So that means if I do a multiplication, okay, if I do a multiplication of 1 by 2 and then add with 3, my 4y, 4 both become 4y and get cancelled. Okay, let me simplify this. So if I multiply the equation 1 with 2 and then add with 3, what I'll get, if I multiply the first equation with 2, I'll get 6x plus 4y. By adding 3, I will get 5x minus 4y. My right side will become 44 plus 0. 4y get cancelled. 11x become 44. So from here we will get x equal to 4. If you get x equal to 4, put back in this equation. So that becomes 5 into 4 minus 4y equal to 0. So that means it becomes 4y equal to 20 or y equal to 5. So y equal to 5. So that means x plus y is 9. So 9 is your answer. So you can do it in multiple ways. If you are not able to identify the first this step, then you can find out x equal to 4y by 5 and put it in any one of the x plus y equation. You will get y and then solve for it. So that is another way. I was just trying to think how we can do it in one step, and that's what we did. Multiply the equation 1 with 2 and add it with 3 so that we can nullify y completely, get the value of x, put back the value, and get the value of y. Simple linear equation. Now let's back to the last problem of today. I've solved around 11 problems today, so there's quite a lot of problem. But given said that you have to solve at least 3x of number of these problems. So if I solve 10 problems, you have to solve at least 30 problems from this area by yourself. So that's the main practice. If you were stuck, if you need some help, and reach out to me. Well, let's say m and n be positive integer if x squared plus mx plus 2n and x squared plus 2nx plus m has real roots. So the main catch here is to identify real root. So if you remember, we said x equal to minus b plus minus root over b square minus 4ac by 2a. This is the generic equation. In that, discriminant is b square minus 4ac, the term under the root. To become real root, b has to be greater than equal to 0. Or we can say b square minus 4ac has to be greater than equal to 0, or b square has to be greater than 4ac to become real. Because if d is less than 0, the things under the root becomes negative and it becomes an imaginary number. So that's not an ideal scenario. So for a real root, that's not possible. So then it becomes imaginary. B square greater than 4ac. So m and n are positive integer, and both of this equation has real root. So x square plus mx plus 2n equal to 0. Now here b square is m square, must be greater than equal to 4ac. So 4 into 1 is x square, 1 into 2n. So I can write m square is greater than equal to 8n. So this is 1. The next equation is x square plus 2nx plus m. Here also b square minus 4ac. So b square is 2n whole square. So that is 4n square minus 4ac. 4 into 1 into m. 4 get cancelled. So n square must be greater than equal to m. So I got two conditions. M square must be greater than equal to 8n. N square must be greater than equal to m. Okay. There are these two conditions given to me. Now, what I have to do is these two other condition. I have to find out the minimum possible value of m and n. So there are multiple ways you can do that. So n square must be greater than equal to m, right? So if the smallest m and n positive integer, so smallest possible value of n can be 1. Let's do some trial and error and see if we can get this. It should be easy. So n is equal to 1. So I know in the here from this one I can write 1 must be greater than equal to m. So m must be, this basically says m must be less than equal to 1. Is it possible? Because it says n square must be greater than equal to m. So m must be less than equal to 1. Not a possible number because m is also a positive integer. Now the minimum positive integer has to be 1. So on the only possibility is m equal to 1. This is possible. So n1 and m1. Now if I put this n1 and m1 in this equation, then my equation become m square 1 must be greater than equal to 8 into 1, which is not a feasible scenario. So n equal to 1 is not possible. Let's say n equal to 2. That's the next possible scenario. N equal to 2 means from this equation what I'll get, 4 must be greater than equal to m. So m must be less than equal to 4. Okay. M must be less than equal to 4. Right? So here m square greater than equal to 8n. Now n is what? N is 2. So n is 2. So from here I can say m square must be greater than equal to 16, or m must be greater than equal to 4. So the first one is giving me m must be less than equal to 4. Second one giving me n must be greater than equal to 4. So the given condition gives me m minimum value has to be 4. So I know n equal to 2, m equal to 4. These are the minimum values. So minimum value of m plus n has to be 6. Okay. A very, very good problem. And that's how we solved it. Right. So if you have any doubts, please feel free to draw up a note. Again, I'm repeating. So if you are with me till now, hope you have liked today's session and learned quite a lot on quadratic equation. We'll do a similar amount of problem in the complex problem session as well, or the problem session 2, which is the next session. If you are liking this, please like, share, subscribe, and feel free to drop your input how we can improve this, or what are the things extra you want me to cover what are the things you want me to cover in a different way. So that will be really helpful for me. And yeah, please like, share, subscribe for the algorithm, and see you next time. Thank you. Bye.